low in medicine. On top of this, no matter how accurate you make an LLM, a doctor...
Dude, I saw a video. It was in the trending video of this guy. He's like a tranny now. And it looks like a female. It had like the whole setup. It was like too girly of a setup though. It's like, but it's like a British guy's voice. And I was like, dude, what's wrong with this? It was really sick. I watched the whole thing. He was talking to his mom, talking to his dad. I was like, dang, this guy has some problems. Not good. But apparently he's like some cross-dresser, some like been doing it for a long time. So it's not a surprise in that community apparently. But I don't know the guy's name, but it was so odd. It's so funny because like it looks like, if I just saw a picture of it, that's a girl. But it was like the guy was like talking and it was like a British man's voice, like this guy's voice.
or medical professional is...
It was like a little deeper than this guy's voice with the same accent. And I was like, what's wrong with you, dude? Just admit you're a porn addict.
is going to want to be provided referenced or sort
Is his
of
name Jaden? Dude, why are you being an A-log? Come on, dude.
information.
Look at this. This is real-time AI genome processing powered by Groq.
Just have to know the source of the information that they're seeing so that they can check and verify it to be sure, period. So, what can we do about this? Well, RAG, or Retrieval Augmented Generation, is a technique used for enhancing the output accuracy and reliability of LLMs.
His name Jaden. Come on, dude. Have some respect, okay? Have some respect for is he still streaming, by the way? Because I don't really pay attention. Is that guy still streaming? I literally haven't even heard of him or like seen him do anything for like the last 8-9 months, honestly. I've seen more of Baked Alaska, and that's just because of that Baked channel on Telegram.
By augmenting the input to the LLM with additional information surrounding a query, RAG can both reduce hallucinations...
Not trying to be insulting, I just don't know. I assume yes because it's not like much else is going on. But is he still doing it?
And allow the LLM to give referenced responses. So, roughly how does it work? Well,
I destroyed his career. Dude, I don't think I did. I think that was like me destroying my own career. That was me sacrificing my streaming career and my ability to become a politician. Because everyone was telling me before that, like, you should need to become a president, run for emperor. And I said, I'm really tempted. I'm starting to get tempted to, and I know that's bad for me. I know it's bad if I do it and I win, I'll be like in charge of everything, and I'll be tempted to do bad stuff with my power. I need to destroy any sort of chance of becoming a successful politician. Boom. So it's kind of like sacrificial in that way, and it's freed me up, and now I'm free to do what I want.
Database of vector embeddings that represent text-based sources. When a series of query comes in, we then compute the embeddings of that. We then perform a similarity search between the query embeddings and the database embeddings.
I couldn't run for dog catcher in this town.
Matches.
Do they still have dog? Is that like a thing that people still do? Are there still dog catchers? I've never seen any reference to that in media anymore.
Returns.
You don't see that much anymore. The dog catcher.
Feed those into the input of the LLM. In these demos, we're going to use a vector database that contains 3,000 genomics abstracts. The medical abstracts are sourced from the PharmGKB
animal
database
control,
and contain the clinical guidelines for interactions
pest
between
control,
the genes and drugs. So, on to our first demo. The gene drug guidelines I mentioned before get updated frequently. And as new research...
Animal catchers just swat? No. There's no animal catchers just swat when they're not like swatting somebody. When they're not busting out somebody's door. They're out just killing dogs in the street.
Published, it's important.
The Nobel Prize for
thank you
goes to us again. Wow.
The cheese nibbler sent $5.
Mouse.
Japanese computer commercial mouse. Oh, this is a mouse commercial. I thought it was like a K-pop band called Japanese Computer Commercial Mouse.
安心でちゅ
The Japanese have taste, dude. Compare that to like an American commercial and just black people. It's just a black guy.
られまちゅう。
Mouse.
No, what is it? But anyway, that really does say a lot that Franson went to China instead of Japan. Being like a trust fund kid, no responsibilities. You can do whatever you want, and you end up going to China to do folk music instead of going to Japan to become like a Japanese folk artist. Kind of says a lot.
To stay on top of it.
That was really good though. But yeah, that's a commercial. That's crazy. You think about what in a commercial in America, it's like a black guy, lesbian woman, fat lesbian woman, some Muslim, and like a Jewish guy pretending to be white who's a moron. And that's an American commercial.
What you're going to see is the genomics database I just mentioned hooked up to our LLM, which in this case is Mixtral.
Oh, the Japanese spank. Yeah.
When I input a query, the output will be presented both with and without RAG.
Joe Bowden
so you
doing?
can see the difference.
Let's
put.
How much did I put in? I put 11 Solana into this. I put 11 Solana into Joe Bowden. 11.3. So that's why I'm telling you guys to buy it, because I want your money. Okay, thank you. Everybody buy Joe Bowden coin on Solana so I can get paid. Okay, thank you. But that's just my play money. Now everyone donate to me.
In a query, which gene variants are associated with adjusted warfarin doses? Here are the two outputs, without RAG on the left and with RAG on the right. I mean, if we take a look at the difference between the two outputs, we can see straight away that there is simply a lot more content being presented with RAG. The LLM without RAG also provides a lot less detail and looks as though it's missing some of the gene variants that are being mentioned here. Furthermore, we can see that the LLM response with RAG is providing PubMed links. These are actually the links to the source information that has just been mentioned. And these are live working PubMed links, so that the doctor can go away and verify the information that they're seeing straight away. Cool. Now, on to the next demo, where we'll use our RAG system in an automated pipeline. Everyone knows what genes are, but processing the entire
what
genome,
are genes?
That's going to be a slow and difficult process.
I heard they're not real. What are genes?
Well, actually today we're going to be using our LLM, in this case Llama 270 billion, and RAG to process a genome in real time. So first, a little bit of context. You can see that it's asking me to upload a VCF file. A VCF file is a variant calling format file.
They're blue pants.
And it's basically a sequence genome. It shows which variants of a
I went to
genome
Buffalo
someone
Wild Wings
has.
today because I got a coupon in the email. It said $8 off. You spend $30 or more. So I got 40 boneless wings, and I could buy one get one free boneless wings, which are more like boneless bites, really. And then also it was like $24, but then I also, because I had to go over $30, I got a Mountain Dew Legend, which is only available at Buffalo Wild Wings. So good. It's like blueberry, blackberry Mountain Dew. Dang, that was good. Yum.
Now, just a second while I upload.
Were you able to stack it on the BOGO deal? Yeah, that was a cool thing. That's why I did it, because it was like, otherwise, who cares? But it was literally, so I got 40 boneless wings for like $20 plus a drink. It's at $24, 40 boneless wings, and Mountain Dew. Smart. It was good though. The mango habanero sauce. Yeah, I got some mango. They have like a honey sriracha flavor, and I got the flaming wild or whatever.
As you can see, our VCF file has been rendered here on the left, and the important column that we want to look at is the ID column, which basically lists all of the person's gene variants. When I uploaded this, we started iteratively processing this VCF file, searching for matches in our database, and summarizing the information found at those matches. So we iterate over the IDs, we find matches in our database, we present summaries of the abstract, and we present links to the abstract.
Dude, that's crazy. So this is their genome. It uploads the file, and it literally look how fast I was with this.
Format file. And it's basically a sequence genome.
A sequence.
shows
So
which
the genome is sequence, which takes time. But look at this.
Variants of a gene someone has. Now, just a second while I upload a file.
So this is a 5 megabyte file he's inputting here.
As you can see, our VCF file has been rendered here on the left, and the important column that we want to look at is the ID column, which basically lists all of the person's gene variants.
And then it goes through and it just, dude, that's insane.
When I uploaded this, we started iteratively processing this VCF file.
I'm going to finally self-improve when this key becomes available. No, if you weren't self-improving already, you're not going to start. Either you're naturally try to self-improve or you naturally don't. And it's not like a bigger tool is going to make you improve more. You are who you are. You never change unless you get into you hit your head really hard.
Searching for matches in our database and summarizing.
It'll just make you more lazy or less lazy depending on your type. If you're if you're always trying to improve or always trying to do stuff, it'll make you more efficient. If you're always trying to consume, it'll make you more consumer.
The information found at those matches.
What about BlueJ? What about BlueJ, dude?
So we iterate over the ID.
Yeah, you can use BlueJ. BlueJ, but that's the thing. If you're using BlueJ, it'll you're already trying to help yourself. This might help you. Yeah, if you're already being helping yourself and doing your best, this might help you even more. But if you're not trying, you don't care. You're probably not going to care about this.
We find matches in our database. We present summaries of the abstract, and we present links to the abstract. And as you can see in the time that I've been talking, we have, generated loads of these. Basically, we've used Groq to make someone's DNA readable in real time. These demos really show that there is space for LLMs in a medical setting, so long as we improve reliability with techniques like RAG. Thank you very much for listening.
You're welcome. Dude, oh yeah, this is the Discord I wanted to hear. This is the Discord. They did an AMA. It's so weird. They're not getting any views. They have 300 views, and the LPU stuff is actually the most interesting. Let's go. Let's log into Discord here.
Welcome everyone to our first AMA ever, and this was actually a decision based upon how many questions we were seeing.
You can tell these people are using. You can tell these guys are using. These are all the type that are legit using the LLM stuff 24/7. This man hasn't seen daylight outside of the Stable Diffusion interface for the last 3 weeks. Imagine the Vouch situation if they accidentally show their generated images. If any of these guys showed their generated image files accidentally, imagine the Vouch situation.
Being online on Twitter and in Discord.
Can't wait to use an AI to make a less mean Paul Town Hall. You're never gonna do that, dude. You suck. You're too weak and you're too stupid. And you'll never succeed.
In a number of other places, and we just thought, well, would you guys be interested in?
That's the AI, Andrew Groq. That's an AI generated person. Now you might think that's an Asian, but you might also say, well, obviously Asians are all AI. But no, that's a literal, completely generated fake person. It's a computer because they can't do white models yet, and yeah, so they decided to do an Asian model. So that's completely visually fake. That person doesn't exist. It's an AI.
An AMA, and we put a survey out there, and the highest vote count.
Asian dude's ears versus eyeline. It doesn't count for Asian people, dude. It only accounts for white presenting people. Asians are a different race. Asians are not European. Now, if you can't tell this guy's Jewish, you're stupid. Let's look at his face. This guy is Russian, you can tell. Igor. And then this guy's Asian.
More about hardware and software. And I said, okay, I think I know the right two guys to answer those questions. So today we've got two of our senior leaders here from Groq, and I love that Igor's using his rock star name today, Igor X. It's perfect for the stage.
All right, I don't care. I do not care. Talk to me about Talk to me about the product. Talk to me about the physical limitations, what works, what doesn't work, the price points, when it's becoming available for people.
Mr. Andrew Links. I'll have you guys just introduce yourselves to everybody real quick. Igor, do you want to go first?
Sure. Yeah, my name is Igor Osovsky. I lead the Silicon team at Groq. Before Groq, I was at Google leading the physical design implementation on the TPU and the various different accelerators there. And before that, I was the CTO of the ASIC business unit at Marvell. This is the custom chip unit at Marvell.
Very cool. Thank you, Igor. And Mr. Ling, looking dapper as always. Want to introduce yourself?
Definitely. Yeah, my name's Andrew Ling. I lead the compiler and software work here at Groq. So been here, roughly 4 years. Prior to that, I spent most of my career building compilers at various semiconductor companies. Focused primarily on spatial architectures, and then that kind of morphed, post the sort of AlexNet craze in 2012 into machine learning compilers. And then I ended up here.
That's awesome. Sorry, I'm getting asked if I want to boost the server because we have so many people trying to get in right now. I'll leave that for the team. They can figure that out if we want to boost it, or we'll just keep this. We'll keep this exclusive to the club we've got here.
This is good because
Cool.
this shows that they're on Discord all
For those of
day.
you that don't know me, I'm the tech evangelist here at Groq and a number of other things that we work on. So what we're going to do today is a couple of things. We actually asked the community what questions did you want answers to regarding Groq at these early days of excitement around Groq with the community. And then we also want to be able to open up to the chat and gather those questions. So my team is watching that, and they're gonna share those across with me so that I can ask those questions on your behalf. So I guess with that, we should just dive right in because everyone's been very, very curious. So I've got the captured questions, guys. I'm gonna jump right into them. And I think the first one is right at the heart and soul of the curiosity. So the question was, what makes the LPU highly performant at inference compared to GPUs? And I think, this is one of those things that we talk about all the time at Groq. Everyone else is a little bit more new to it. We get compared to GPUs a lot, the methodology that people traditionally evaluate GPUs. But the person added to the question, they said, we've heard about deterministic approach to reduce latency, but we actually want to understand the specifics on how this is achieved. At least anything that you can share publicly. So let's start with Igor, because, the secret sauce is the hardware, but the hardware was designed because of the software compiler coming first. So let's start with you first, Igor, and maybe explain that advantage for us.
Yeah.
Igor's about to be like brains.
Let me bring up a slide. It's much better if you have a visual to it. So let me know if you can see it.
I see something loading.
Okay.
Yeah, I'm not gonna. This isn't even live, dude. This is what I want to see.
There's an alert symbol. Do you not see it? I see it on my side.
Andrew, do you see it on your side?
No, it's still loading.
Still loading for me too.
Dots.
Okay. Oh, weird. Okay. Okay. Let me start talking about it, and then hopefully we can figure out what the loading problem is. Not yet, classic. Okay. Okay, it's funny because it worked before. All right, so let's kind of dive into it. If we look at the LPU versus the GPU, so the GPU was something that was developed for the purposes of graphics processing. So it is a device that kind of started being developed about 25 years ago for the graphics acceleration. The device contains a large number of cores that are all executing in parallel. And these, can you guys hear me?
Very nice, Gus. Very nice.
Yeah, I can hear you.
Very proud of you.
Yep,
Keep it up.
These cores are executing in parallel, and these cores are really non-deterministic in nature. What I mean by that is that the time to complete a specific task by each of the cores depends whether the data that you're working with is in your level 1 cache, or whether you need to grab it from the level 2 cache, or you need to go into DRAM, and in which case the DRAM kind of latencies to access that data takes a long time. And when you have lots of non-deterministic cores like this, you're kind of at as slow as your slowest core. And then when you work with multiple chips like
Trump
this,
is going to fact check these after the stream.
As slow as
He has a recap
chip that has
stream.
the slowest core, and kind of you have this at every checkpoint during the execution of a specific program. The LPU works in a very different way. It's fully deterministic. What we mean by that, we don't have a memory cache hierarchy. We just have flat access to memory, which means that we can access that memory directly, and we can predict where the data is moving on the chip down to a nanosecond. So this is really helpful on the hardware side, because you can actually plan your hardware in a very regular fashion that's really efficient. But it also helps on the software side to kind of easily place algorithms into the hardware. So can you guys see the screen that I'm sharing yet, or not
No,
yet?
it's still. It looks like there's something on your account side that it needs to be addressed. Although someone says they can see. Wait. Yeah, some people say I can see. Others say screen isn't loading. Looks like it's a mixed bag, depending on who's getting it and who isn't. It says there is LPU inference engine on screen. So
yeah. So maybe if somebody can bring up my AI Epiphany slides, Mark, I don't know if you have access, or Andrew, I can share these with you. But what I'll do in the meantime is kind of describe it in a little more detail. So on the LPU side, this is a silicon that was implemented in 14 nanometer. So this is a very simple piece of of hardware. It's
that's the crazy part. That's the crazy part. This is 14 nanometers, which is really small. But I think people get down to 3 nanometers for other stuff. And I don't know how it's done, but I think like 3 or 2 is when it starts getting too small to accurately do properly. People say it's because of quantum stuff. I think it's just because it's impossible. It's like very hard for people to do it properly. And I think it's just like coping, because nobody wants to actually do it. But I could be totally wrong. But I don't believe in quantum stuff. But so if it's already, there's not that like, it's not hard to make in terms of what they're saying. I'm sure it's hard to make, but it's not like some super crazy technology, which is kind of crazy. It's very cool.
Single chip module, no HBMs, no large CoWoS silicon interposer. The cost of this device is about an order of magnitude more cheaper than like a GPU like H100. And yet we're achieving this amazing performance out of this device. So I kind of touched a little bit on the chip side, but the story really spans across the system.
This is an order of magnitude. So an H100 price. $43,000. What's an order of magnitude less than this? Let's go to Claude. What's an order of magnitude less than $43,000? Which is still pretty cheap, honestly, for how fast it's going. Yeah, so $4,000. That's insane. If that's because, that's just crazy. And it sounds like they're getting these results from one chip. That's what they're saying. But I could be wrong. I could be misunderstanding.
System, not just at the chip level, but at the system level and the software above it.
Oh, yeah. Order of magnitude just was one. All right, I'm retarded. I was thinking of like exponential.
I'll let Andrew kind of maybe talk a little bit about how this determinism and the predictable kind of hardware behavior enables the software to kind of move quickly and achieve really high performance. So maybe I'll stop there and try to figure out how I share better on this channel.
Yeah, perfect. Yeah, go for it. Go for it, Andrew.
Yeah, I mean, oftentimes the way I like to think about it is first just understanding, how existing substrates and technologies solve these LLMs. So let's take a look at multi-core CPU or graphics cards for that matter. How effectively do they actually run these things? So this is getting a little bit into the weeds, but if you take a look at a typical LLM, it's going to be a chain of
A typical
20
LLM?
decoders, let's say. So Llama 2, you got 80 decoders. How's that actually run on a CPU or a graphics card? Well, they basically just run it serially. So they'll take the first decoder, run it on the silicon, dump the weights back into HBM. And then dump.
Order of magnitude is exponential, except it's base 10 instead of base 2 or base C. Yeah, you know what I mean. You know what I mean. Sorry. You know what I mean. In terms of 10 to the, or 5 to the 5th power, 5 to the 7th power, that sort of thing.
The activations back in, and then they'll run the next decoder. So decoder 2, and then 3, and then 4, and so on. So they're effectively time multiplexing the hardware.
Oh, he looks like Andrew Yang. He looks like the Yang guy. Yang Gang. That's what he looks like.
So what are we doing? We're basically flipping that on its head. We're actually scaling across space as opposed to time. So imagine now I have one dedicated chip for each of these decoders, and they're running in kind of like this pipeline parallel fashion, kind of like an assembly line. That's effectively how we're doing it today, and that's why we're so much faster. So the natural question, so what? You're deterministic. How does this interplay with all this? Well, the fact that we are able to scale in space makes this, the only reason this is possible is because we are deterministic. As Igor alluded to, if you have no idea.
You guys are kind of signaling the movement. I'm going to ban you.
Each of these chips is going to run, you're going to be overly conservative in terms of getting the data from each of these chips. So ultimately, your slowest chip is going to determine the performance, and you end up being super slow as you scale across each of these chips. That's exactly the problem that you see with these non-deterministic CPUs and graphics cards, because they can't really decide how to split up the problem in a clear way to effectively use these chips in a pipeline parallel fashion. We don't suffer from that, and that's ultimately why we get these blazing speeds across Mixtral and all these Llama models. So hopefully that makes sense from a high level. Yeah.
Yeah. So I mean, I guess the key takeaway is with the more traditional incumbent architectures, what you guys are saying is you can only be as fast as the weakest link in that system, right? And we don't struggle with that. And I like the factory analogy. We've talked about this before. For anybody that has ever studied the industrial,
what is their product? It's Groq. It's G. It's not the Twitter Groq. It's GROQ, and it's called an LPU. It's not a CPU, and it's for LLMs, and it's really, really, really fast. It is a way. It's like a different. This is what they're talking about, but it's a different architecture, and so it basically is not using a GPU. It's not using like a graphics card to do the calculations. And so as a result, it's like 10, 20 times faster than GPUs.
Revolution, what made the factory line so powerful was that once upon a time, if you built a product, your workers would literally walk to different stations, moving the product around the factory, right? And so that caused you to be very slow, have issues between each station as they're doing the work. As soon as they figured out to bring the tooling to the factory line, and one line was where everybody sat and worked on it as the product moved through, suddenly they gained all of this efficiency and reduced risk to the product because you're not moving it off of the line. It's sort of the same idea. That's in essence what you guys are describing, right?
Oh yeah,
I think I think it's a great analogy, Mark. I think it's in the GPU case, you're kind of using the HBMs to store your machines, and you bring them onto the main floor, which is the key die, the core die, and you operate on a specific data, and then you bring new machines from the storage. The problem is when you're bringing these machines from your HBM to your factory floor to do the next level of processing, that costs both power because you're moving a lot of data back and forth, and also the bandwidth from an HBM, even though it's called a high bandwidth memory, it's still like drinking through a tiny little straw compared to the SRAM bandwidth that you have on a chip, right? It's about 100x times lower bandwidth to a single HBM versus the SRAM that we have on our die. So we can get that a lot. We can get a lot more processing done versus moving data back and forth.
Yeah, I liked the analogy that I heard the other day. It was a little bit like driving on. Hatija will appreciate this. Driving like the exits in New Jersey, where you have the teapot kettle roundabout. You have to go round and round and round every time you exit off of the freeway before you can get back on the freeway. And we don't have that problem. Well, let's jump to the next question. I apologize to everybody. It seems like some folks are seeing the screen, some folks are not. I actually saw it for about 8 seconds and then it disappeared again.
All right, we can see it now.
Might be
Don't
a
worry.
Discord thing with our first time trying to use Discord for this. Okay, so the second question that we got is, do you see Groq chips only being used for LLMs, or do you believe there are other good use cases? For example, can Groq accelerate processing questions in computer vision AI like NERF, or is it really just good with LLMs? And I think this is funny. I'm going to point this one to Andrew first. I find this really, really interesting because we've been around obviously for nearly 8 years. And if anybody looked at our videos from our early events, I mean, we've done GNNs, RNNs, we've done computational fluid dynamics. We worked on drug discovery models with the national labs. But, I think getting into the weeds of it, Andrew, is it just LLMs? What's your perspective from the compiler?
Yeah, I mean, you're absolutely right there, right? Like, it's a superset of LLMs. So we do have the world's fastest LLM accelerator in the LPU. That's definitely true.
Mm-hmm.
But let's decompose the LLM problem. Like, what is it? Is at its core, the biggest operations are a bunch of matrix operations, right? So naturally, that's going to help other workloads. So things like CNNs, things like graph neural networks, we fundamentally will still be able to be effective on those workloads because we have these think of them like these heavy hammers on the sides of our chips, which are really just linear algebra solvers. In addition to that, like the chip is essentially, it is Turing complete, right? Like we have a full set of instructions to actually take care of these nonlinear functions that are quite common with all these machine learning workloads. And so that in conjunction with the matrix engines on the end makes the chip very versatile. And this is more than just like, words. Like we have seen this with our customers where they've sped up key applications, 10x, 100x in drug discovery. And
that one was huge.
Fluid dynamics, all these things, we've seen these accelerations. So the chip is actually quite versatile, surprisingly, because usually you think, oh, they're getting this fast, it must be all it can do is transformers. No, there's definitely going to be companies which take that strategy. It's like they're going to be transformer machines, just like in the Bitcoin era, they tried to make custom Bitcoin machines out of ASICs. But you saw how fast that space kind of died, right? Because the space is changing too fast, right? Like transformers may be a good basis for today, but who knows what's going to happen in 2 years, how these things will evolve.
Yeah, and I think I've seen Jonathan use reference to like a Galton board, right? It's really
I have no clue what any of this means. What they're saying is they're building specialized hardware and they've been working on it for a while to essentially do the way that programs work that do AI now, whether it's on your computer or whether it's whether it's ChatGPT or Claude. Those things are using these very specialized graphics cards that are like designed, like very, very powerful. You can get a 4090 or 3090 with a lot of VRAM, or you can get an A100, right, or an H100 or an A500, I forget what it is. Like industrial, like it's like the way it works is not optimal. It's not super efficient for this type of calculation that the computer does. And this chip that they're making is essentially way, way faster because it's properly organized. And that's why their site, if you go to Groq, Groq.ai, I think. Like if you go here, Groq.com. This is an LPU inference engine. It's not a GPU. What's an LPU? it just typed that out, and that's 524 tokens per second. Whereas if you go here, go to Claude, right? What's an LPU? This is a paid for version. This is a So we don't care about the data. We don't care about what it's saying right now. But this like takes way longer, right? Whereas this, I don't care about the accuracy. This is so much faster. This is probably like 10. This is probably like 8 to 10 times faster. And so it took about half a second. It took about half a second, and this took about 5 seconds. You're not reading that fast though? Yeah, you don't have to read that fast. The thing is, if you get stuff going this fast and you make a machine that goes this fast, then you have this, and then you can make it pass through like 3 versions. So you have you ask a question and it gets 3 answers from 3 different models at the same time. And then it takes those 3 answers and compares them and then creates a better answer out of the 3 answers from 3 different models. And so then now it's not as fast, right? And now it's a little bit slower. It's still a little faster than this. But now it's exponentially better because you can now pull from different models, and it's like a good recipe isn't made from one ingredient, making it really fast. It's a bunch of different ingredients, and so if you can do things really fast, then you can you can include a bunch of different ingredients to make a really, really good dish. If that makes sense. Whereas with something that's this slow, you really don't have time. You could still do the same thing, but it's going to be so slow that it's just it's miserable. Whereas with this, you're going to be able to combine a bunch of different models, a bunch of different types of the same type of program, and then create really complicated things and really, really high quality answers, just because you can do a bunch of different you can do a bunch of different layers of calculations, if that makes sense. And so it'll be awesome. So basically it's going to increase AI speed. No, it's going to increase the quality of it too. It's going to open up a lot of different things that are not really feasible right now.
That's linear. And where are you advantaged in the way that you process data in a linear fashion, sort of like you said, hammers on the side of the lane that are processing that data more efficiently, right? And I think once you start getting to data center scale, that really shows its value.
Yeah.
Yeah, and I would invite people to be curious and go actually back to our early days of our YouTube channel. We even had I think it was the 2nd gen of YOLO on there, and we were doing some computer vision with YOLO. We did a really cool blackjack game. We've done all kinds of radical things. And even on the drug discovery one with Argonne National Labs, that model, which was a completely custom implementation, and not a huge system, their original system was processing that model, looking at drug compounds sticking to a protein. I think it was taking 3.5 days every time they'd want to run a drug compound. And we got that down to around 17 minutes each round of the simulation. I mean, it was
think about
insane how much faster we made that. But it was because the implementation was really complementary to being linear. And the same thing when Adobe suggested we do the style GAN model, right? When we mapped those styles, and we have that video up on YouTube as well. They originally said this runs at about 7 seconds per round.
These guys make hardware. And
we got that down to well below a second, running actually 8 styles at the same time. So it's quite impressive. So this one comes up a lot. I'm going to ask the next question. Is training coming? We get asked this one all the time. Igor, what's the answer here?
I think as a startup, we got to stay focused. So right now, I think inference is the focus. We want to drive that hard. The architecture itself, does it lend itself to training? Yes, I think a lot of the benefits transfer, but inference is our focus. Yeah, we have a small team. We got to execute well. We're going to stay focused.
Yeah, and I will say there has been. Yeah, go ahead, Andrew, please.
No, yeah, just to add to that, ultimately from a business perspective, the chip, like I said, is Turing Complete. We can do training, and we have done training in terms of our internal applications. But from a business perspective, the market is where inference is at today. Mm-hmm. I think Jonathan always says this, the number of inferences scales with the number of users in the world.
Will it use a PCI slot, or are they not there yet? I don't think it uses I think it's like a CPU type thing. I could be off. I don't know enough about computer hardware stuff. I think it's like similar to like a CPU, in terms of how it connects to the computer. I don't think it uses I don't think it's like a GPU type connection. I think it's literally like a chip, not a card.
Whereas training, it scales with the number of ML engineers, right? ML teams, which is much, much smaller. Mm-hmm. And even when you look at the industry today, because training has been so expensive and hard to do, it's almost like the industry has kind of...
Yeah, training, I think it probably will be able to. But I think that's when you start, like, it costs some crazy amount to make a model, to make like a good model. It costs some crazy, like, millions of dollars to train a model, and it takes like months or something like that. So it's not that, I don't think it's going to be like really available, but you don't need that. We really just need the inference, which is like the taking input, running it through a model, getting output, because you don't need to be super accurate, because you can scale it hard. You can scale it with multiple models and then checking against multiple models. Ideally we get to the point where you can train stuff too, but this is like a crazy thing. The inference part is really the front end stuff, and it's really I think we're going to end up with a bunch of different little models that get combined, because that's, if they're very, very specifically trained for math, very specifically trained for science, very specifically trained for history, for whatever, and you kind of like plug and play them like Lego blocks into like a brain, and then you can have different, like I went over this the other day, but like essentially you have, I don't want to bore you guys, but essentially you have like a brain, and then you have a model, a model for one thing, a model for another thing, and a model for another thing, 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 and you have submodels in there, and you, like, the brain gets asked a question, takes the question, and it brings it over to this, and there's this type of model, there's 5 of them, there's 5 different models doing the same exact thing, if it's this category. So then this category, let's make this a triangle instead, then sends the same question to these 5. They all spit out answers. All these 5 answers go over to here, which is a model right here, which then compares the 5 models. Or you could even have 5 models here, right? You could have 5 of these models that are then kind of like a board that take the answer from this board. And this one comes up with this answer, this comes up with this answer, this comes up with this answer, this answer, this answer. And the more times you can do this, and then these answers, all get compiled together for 5 different opinions, and it goes to a final brain. And then the brain says, all right, well, of this board 5, this is what, this is the reality. And then this is your answer. So the more steps you have, the more time it takes, but the faster you go, the less time it takes. And then as a result, you can actually take really small models and get very accurate answers, if that makes sense. Yeah, a GPU is really, really good. Why get this instead of 4090? Are people just poor? Yes. No, it's way better than 4090. It's way faster. It's super fast. And it can scale too. Because it's linear, you can get multiple ones apparently. And you can get like multiple chips, have them all like linked together, and you can get like crazy speeds.
Pivoted away from needing it because it's so hard. And what I mean by that, what you'll find is, well, a lot of companies, unless you're a Microsoft, unless you're like one of these big tech companies that can afford the servers to actually do the training, you're
Right.
fine with just a foundational model and tweaking it. So what I mean by tweaking? LoRa's, fine tuning. It's 1,000, 10,000x cheaper to do that. So training is actually a shrinking area, and it's
Right.
hard to actually create a sustainable business around training right now, which is why we're focused on the real problems that people are facing.
Yeah, and it's definitely not our focus. I do know we have one customer that did use Groq for training, but it was such a unique and novel use case. It was sort of out there. So okay, I think this next one is I'm just going to take this one. Are Groq LPUs PCIe cards? Yes.
All of the above.
I have the technical aptitude to answer that one.
Yeah, what did he say?
Anything you want to add to it, though,
I
Igor?
don't even know. It doesn't matter. Who cares?
I mean, I think the architecture lends itself on anything from embedded IP on a chip all the way to the cloud. Really, it is a unique architecture, and the beauty of it is that it's simplified, it's regular, it's easy to program. So the software solution that Andrew's team is providing kind of spans that whole gamut of different.
He says
form
yes, it is
factors.
PCIe. Okay. Once again, I don't know enough about this to even say what. Because I don't know things. I don't know. Is it going to be consumer? Is it not going to be consumer?
That we can deploy it in. Our current focus is LLMs. That's the sexiest thing on the planet right now. So we're pushing there, but technically we can go across the stack. Yeah.
Awesome. Yeah, we often say sand to sky.
Yeah.
Okay, so this one's popped up a bunch in Discord and on Twitter. Are you planning to do function calling? I know this is really getting deep into the sort of the ask of the developer community. Andrew, do you want to address that one?
Yeah, I mean, the short answer is yes, right? I mean, this plays in with some of the recent
PCIe is an expansion slot under the video card. Oh, okay.
announcements. So we've essentially acquired Definitive, a relatively successful but small startup. That team has a strong expertise in machine learning applications and cloud infrastructure. And the proof is in the pudding. You really have seen the acceleration of all these applications and interfaces and APIs like function calling, which we do plan to serve to the community.
Yep, it's an exciting time. We're learning in real time with the community what it is that everybody wants and where should we focus our efforts. I want to give a quick shout out as well. I see a lot of comments in the chat, and I see that we've got some Groqsters in the room as well answering those questions. Thanks, y'all, for doing that. I know those are very specific things that people want to know about. So please keep supporting the community there and moderating. Okay, so now we're going to get a little
PCIe is those wides. Can you connect to your graphics card? Oh, yeah, I know what you're talking about now.
more into the
I remember now.
weeds of the models. The next question that came up. Do you have an enterprise version where we can run specific Mistral or Llama-based fine-tuned models, which are fine-tuned on our data? Can we upload our own weights file? Andrew, you mentioned fine-tuning earlier. What would you say about this?
Yeah, I mean, the short answer is like the technology obviously supports it, right? Like you have a different set of weights. We can suck that in and update the programs that are run on the LPUs. In terms of a model serving API to enable this, again, related to my last answer with Definitive, like this is something that we will definitely enable in the coming months in terms of allowing our own customers bring in their own weights and running it on our LPUs.
Perfect. And I think just in adding to that, where it says specifically Mistral or Llama based, this is one of the things that we're also monitoring very, very closely, which is what is the next model the community wants? What is the open source world really driving us to? So not only, is Mistral and Llama what we offer today.
I don't care. Give me the hardware. I don't care about the software.
That gets dropped. I think everybody's curious about Llama 3. Everybody's wondering what Mistral is going to do next. And so at the same time, we're looking at what those features and services might be. We're also monitoring what is the next model and, whether it's another MOE or something similar. So exciting times there. Igor, this one was, I think, for you, shifting a little bit to the business side. What would the specific impacts to Groq be were there, let's say, a drastic political unrest in Taiwan?
I think from the Groq perspective, obviously nobody wants anything like that. I think it's going to be a big impact of the world. But from the Groq perspective, we're fairly isolated. So if you look at our chip is manufactured in upstate New York in Global Foundries, Malta.
Oh wow,
New York.
That's crazy.
It's packaged
Global
in
Foundries,
Beaumont, Canada, which is a couple hundred kilometers up from Malta, and then
that's cool.
The folks that are kind of programming this chip and kind of the software is in Toronto, where Andrew is and his team there. So we are probably really well isolated. We don't have dependency on HBMs from Korea.
Yeah, it's 14 nanometers. It's not as precise. It's not super precise. in terms of the manufacturing. They have room, which is kind of crazy too, because if they have room and it's super precise, not super precise, that means that if somebody else can make something more precise, it'll be even faster, probably. Or I could be wrong.
Us from Taiwan, so it's really we have a perfect kind of architecture that's assembled here in North America. Yeah.
Yeah, we're quite neutralized, right?
Yeah.
Which is good. And then to even expand on that, and we'll probably talk about this a little bit later based on some of the other questions, but also our next chip is actually being fabbed in Taylor, Texas. So we're going to be able to stay with that neutralization. So it's quite stable for us. All right, this one's
Did you buy Bowden? Yeah, I bought some Bowden. I couldn't resist. How are we doing? What's the deal? Yeah, I bought about 11.3 Solana of Bowden. I couldn't resist. I said I'm gonna put all my money into Bowden. So sure enough, I did. And so, ooh, it's over. It's over. There we go. So I figure he's about to give a speech, so it'll go up. It's logical.
Andrew,
It's just logical if it goes up.
heavily invested in constrained generation. And one thing that no one seems to have done, but would be huge, is to constrain the generation and
Very interesting choice. I wonder if it was cheap fab space or decision to be in the US. They were doing it since like 2016. They've been working on this not just for LLMs, but for like whatever this type of like calculation. So this isn't new. It's just they've been doing this for a while. Like if you go to their channel, Groq, this is they're like actual hardware people. Oldest 4 years ago.
Execution and multiple branch prediction. Multi-core only compounds this problem.
So they've been doing this for a while. It says 4 years old, 800 views. Even this, it's crazy because this works. Like this is right now public, and this only has 300 views today. It's very odd that they're not really getting more attention, in my opinion, because this does like, unless there's something I don't know that is like making this impossible or not cheap. It's kind of weird to me that this is not being publicized more.
Inject context dynamically in the middle of generation. And then they've got a series of examples here where the LLM is taking the outputs and then making sure that those numbers as it outputs conforms to a rule and a sequence, etc. But I think the high level here is, prompt engineering. So maybe you can offer a little context here.
Yeah, I mean, ultimately the team has exposed a pretty general API. And even internally, I think there was a video that we posted where we did show a RAG demo, for example. Yeah. And so that the way I would look at it is, as long as you can access that API and you provide the right prompts, you can massage that however you want. And obviously, we're going to add tooling on top of that, again, with our partners at Definitive to build this out such that it's a bit easier to use.
They still haven't answered. I'm not really happy, but they still haven't answered if it's going to be a consumer. If it works, it works. I don't know why. I think they probably just can't compete if they're selling stuff physically. I don't know. We'll see. Because if this works, which it works, that's the thing. That's selling this as a card or selling this as a chip.
Yeah, like I think this is perfectly in line what we plan to do to empower our users to enable these interesting applications and get more sophisticated prompts into our system. So yeah, absolutely.
Yeah, and I think it goes back to your Turing complete comment, but the other part of their question said, is this possible with your hardware? Could you support it without changing the hardware? And obviously we could. Because of it being Turing complete, right? And I don't think a lot of people are aware, because when they access the API or they go to Groq Chat, they see a couple of models. But actually, the last I checked, and you probably know better than me, but last time I checked, hundreds of models were actually compiled from Hugging Face in our system. Do you want to talk to that just very briefly? I'm going to add it into our list.
Yeah, absolutely. Yeah, like I mean, this goes back to do you do more than LLMs, right? You have an LPU. Like ultimately, the compiler was generated in a way that was essentially agnostic to workload. I mean, there's some salient characteristics about machine learning workloads. Their data flow graphs, relatively static. So those things played to our strengths. But beyond that, we're not really doing anything specific. Like we don't have kernels in the compiler. right? We're not
That still blows. That still blows people's minds. It never fails when we're at an event and we go, yeah, and we don't have any kernel elves or kernel, there's no kernel thing going on, and people go, yeah, but you're kernel. And I'm like, I don't think you heard the words I just said. There are no kernels. So maybe elaborate on that a bit.
Yeah, I mean, 100%. It's hard for people to understand because everyone is thinking about things from like a graphics card or CPU framework, right? Like that's the worldview. So of course, you're building kernels because of course, you have reactive components with the hardware. Of course you have to do that. No, we've kind of flipped everything on its head. Like we have deterministic hardware. There's no reactive components. It's 100% transparent to the software. So we don't need to do that. Like we've essentially simplified the problem for ourselves. And don't get me wrong, like the problems that a lot of the big companies are facing and like how they're building out kernels, it makes 100% sense for them to take that strategy. It is the right strategy for them to take because it's not a solvable problem, quite frankly. It's an NP complete. People have been doing this for decades, and ultimately they've stopped, right? They've fallen back to these kernel libraries because that's how you get the best possible performance. We don't have that luxury.
I need to get some blue cheese. I'll be back in a second. I want to pause it. This is like the most interesting thing. Not the only interesting thing, but the most interesting thing going on, in my opinion, is this company and their LPU stuff, which I don't really fully understand. All right, we're back. We're back. It will free up more time for shit posting. All right, here we go.
We don't have 1,000
Dude, this is so cool though. This is so cool.
engineers just writing assembly code. So we had to do something different. Otherwise, we wouldn't have survived, quite frankly. That's what it comes down to.
Yep. And that's where it became radically novel, right?
Yeah.
Awesome. Well, and speaking about like those sort of problem statements, I see one of the questions someone offered, very specific. Does the compiler need to use backtracking in case it paints itself into a corner, or do you have tricks to avoid that? I feel like somebody's been reading an ISCA paper.
No, it's a fair question because again, when you come from like a CPU world or traditional scheduling, you're going to hit this problem, right?
Yep.
Again, NP complete problems. You have reactive components. You don't know when vector X is going to go to, hardware component Y. Those things are non-deterministic in a lot of respects.
Is this Temple OS style? Is that right? Is it Temple OS?
The way we avoid it is effectively we don't have those problems. Essentially, if you take a look at the architecture, it's one-dimensional. Mm-hmm. It essentially becomes a 1D packing problem. And so you really just have to go forward in time, no backtracking, and just schedule things back-to-back, vector by vector. And that's effectively what we've done. That was Jonathan's vision from day one.
Yeah.
And it seemingly seems obvious now, but it's actually really hard to grok and understand because it's so different. Like effectively, we're avoiding those NP complete problems that you have to deal with in other spatial architectures, CPUs, graphic cards. We just avoid it,
Yeah, and I think even at a business level, high level, we've been asked in the past, like, oh, why aren't you doing these traditional benchmark sites, and why aren't you doing these other methodologies? And of course, our answer has always been because those were based on how GPUs were engineered, and then how you test them at that scale, right? And it's just not the same thing. So we're really happy now that there's sites out there like Artificial Analysis and Anyscale that are sharing these leaderboard benchmarks that allow us to really demonstrate inference, purely as a service and at scale. Let's get to the next one because it's getting into a system level conversation. So far, we have Groq's token throughput per user, but we haven't been given the token throughput of the entire system.
Oops.
This person said, been given the token throughput of the entire system. This person said, I believe this is an important metric for assessing the effectiveness of Groq's inferencing capabilities, and with it, I could express my support for Groq within my company. We serve local inferencing capabilities to various clients. So here's my question. The question is, what is the token throughput of Groq system built to run Llama 2 70 billion FP16? And how about a Groq system built for Mixtral 8x7b or FP16? Is there any information you can offer about this? So I'll start with Andrew, and then I think we'll turn to Igor at the system level as well.
Yeah, I mean, it's a good question, right? Like,
Dude, they're crashing my Joe Biden coin.
we have these
My Joe Biden coin.
They're cranking out extremely good latency, but ultimately, what's the overall throughput, which ultimately translates to the cost of the system? I mean, the way we handle it is effectively, I alluded to in the first question, really, like, how do we actually execute things on the Groq chips? And we execute them using pipeline parallelism. So what that means is we're going to have multiple users concurrently within the hardware or system kind of executing in this sort of assembly line fashion. It's like going down this train, so to speak. And that's where we can get the massive throughput gains such that this is extremely cost effective. And the proof is in the pudding, right? Like, we have our Groq API up and running already today. Mm-hmm. It's serving thousands of users, thousands of requests concurrently. Like, it would be impossible to do that basically if we did not have this feature implemented today. So we're already implementing extremely high throughput with the overall system. But there's still a lot of room to grow. Right?
Yeah.
Yeah, go ahead.
I was going to say, I looked at one of the dashboards the other day, and there was a narrow time slice with a spike. And I think there was just in that particular instance, that few seconds, there was something like 3,200 users making more than 37,000 requests, within that narrow time slice of a spike. And it was just, when you look at that and zoom out, suddenly you get into the millions and millions of requests. Igor, what do you think about this in regards to the system, the overall ability to serve requests, and then I guess where is that going?
Yeah. So Andrew pointed out, I mean, the throughput is already kind of there to support millions of requests, thousands of kind of users already. We are a small startup, so there's limited amount of hardware just yet, but we are ordering hundreds or thousands of racks that are coming in basically to kind of satisfy the demand that we have. But we also have to realize that this is really early days for Groq, right? Like, we like to compare Groq to somebody that's kind of super established, like GPUs with massive amounts of deployments, and kind of to try the comparisons. The reality is GPUs were developed, 25 years ago for the purposes of graphics. They're kind of are tapering off in their kind of improvements. It's more of an evolutionary improvement. What we are seeing with the LPU is more of a revolutionary improvement, right? And here we're already seeing like really great throughput, and then that is kind of going to ratchet up on multiple fronts, right? So we have 14 nanometer silicon right now. So all these amazing achievements are being achieved with the 14 nanometer single chip module silicon, right? So we're kind of we're fighting with two hands tied behind our back right now. So on the silicon side, we're moving to 4 nanometer. If you just look at Moore's law scaling there, you get a couple of X improvement, 3-4X improvement just in technology improvements alone. Then you add to that any learning that we have taken from the previous design, any architecture improvements, new kind of interconnect, better systems on top of that. So all these things are just really multipliers that are just starting to come in, right? And this will continue, right? This is a new architecture. We're going to be improving it and driving that. So we are on that very steep curve right now, and we're just at the beginning of that steep curve. So multiples are coming as an improvement versus something that's kind of sitting already at state-of-art silicon at 4 nanometer with 6 HBMs with CoWoS. You've kind of brute forced this to that point. I think we're just gonna skyrocket past that. So this is the exciting part about being at Groq. And then there's the deterministic architecture just opens up so much silicon optimization, system optimization opportunities that really do not exist on any other systems that I've seen out there. So
yeah, and I know a lot of people have been curious.
Yeah,
about
that's so
this.
cool, dude.
You know, if we were just to brute force 14 nanometer to 4 nanometer, you know, back of the napkin math, if we did no optimization, no change whatsoever, we're just shrinking, right? What would happen? Like, what does this gain us?
I mean, you can get like 3-4x just for 14 to 4, just like that alone. But then you have to look at C2C latencies and bandwidth, and those are one of the key differentiators. Those are moving significantly more than the 3 or 4x. Then you look at system improvement of perf per TCO. We want to actually deploy very efficient systems that kind of give us the best cost per LPU deployed. All these improvements are yet to be brought to bear here, and we just need money and time to get it across the finish line. So
yeah, it's fun. So I know this one wasn't in the list, but I've heard this question come up, so I want to take the moment as an opportunity. Andrew, you know, we talk a lot about going from 14 nanometer to 4 nanometer. Obviously, there's other optimizations that we're putting in there that are going to be dramatically more than 4x. That roadmap is very exciting. What does this mean on the compiler side? Do you guys have to reinvent everything? Do you have to go back and start over to work with this new scale? Is there some dramatic change that has to happen for you here? Or does this generationally, what you and the team have established in the compiler, is that now the foundation of an entire generational movement of processor category?
Yeah, I like how you phrase it. Like, it's definitely in that latter category. Like, ultimately, you know, each time we hit something that's different or a new level of scale, what we ultimately often will do is just enhance what we've already built, and then those benefits move forward with the technology and software stack in tandem. Like, it just kind of carries forward. So anything that we do today in terms of optimization, it's really paying dividends. And again, this stems from the fact we are not doing custom kernels or one-offs within the compiler stack. Yeah. The idea is, okay, let's come up with generalized heuristics and generalized approaches to our vectorizing compiler and multi-chip compilation approach. And then through that, you know, specific instances like the latest and greatest Llama variant, you know, Llama 3 is coming out in July. They may expose some sort of esoteric nuance to a heuristic that we have to enhance, but we're sort of carrying everything else forward with us.
Right.
We're not kind of like, oh, there's Llama 3 now we forget about Llama 2, so we have to like rejig everything. No, it's kind of, oh, there's Llama 3 that complements what we're doing already. Let's enhance that, and now everything else kind of lifts up. That's the general approach.
Yeah, I love that. I think this leans into a topic that I'm going to jump ahead in the queue, and then I know we have a couple of live questions I want to get to as well, if possible. And don't worry, guys, we will do more of these. If we don't get your question answered today, we're learning how to be Discord people. We'll do more of these.
It's over.
So you talked about how we're carrying this forward, right? I think the one thing that we haven't broached today is what we often call developer velocity. There's a lot of people that are on the call that are developers that are really excited. Obviously, we recently acquired Definitive Intelligence. They're leaders in the developer world and deeply experienced. So because you're able to carry so much of the foundational work in the compiler forward, can you talk a little bit about what is it like, or what's the vision or the goal for the developer experience from your perspective?
Yeah, the ultimate goal is to ensure that the developer focuses on their problems and they are not tying their solution to any specific implementation. So what do I mean by that? Like, look at PyTorch, right? extremely powerful framework, extremely popular. I'm sure a lot of the developers are using it here today.
Sure.
But what's the biggest pain? Like you have to oftentimes, in order to get good performance, customize your PyTorch code to the underlying substrate technology underneath. Simple example, convolutions. How many convolutional operators are there in PyTorch? I think there's almost 100, right? Like,
Right.
and they're all kind of doing the same thing, but they're tied to specific implementations.
Mhm.
Like there's like, you know, CNN, ReLU, Intel DNN or something like that, underscore blah, blah, blah. And then they'll have one for another vendor. Like it's overly complicated. So that is something that we have to help the industry move away from.
Mhm.
And because, again, we have the automated vectorizing compiler, we have this versatile architecture with on-die memory, high bandwidth memory on chip. We don't have to do that. And so that's the ultimate goal, is make sure that developers can move fast on their own and they don't have to kind of shim themselves to any one specific technology.
Yeah, they're sort of the tax of the previous solution becomes the cost of tomorrow, right?
Yeah.
It's very much in that space. Someone asked a question related to this, and I know we're going to be wrapping here pretty soon. But this person, I think, related to that, it looks like it's an Xargon friend. They said, are all common functions operations provided to developers in PyTorch, TensorFlow, CUDA translated or usable on device along with saved weights without needing to redefine model architectures?
Yeah, I don't know if this answers the question, but like how we actually approach this is we decompose all those PyTorch operators into a canonical set. That canonical set is maybe, 50-ish operators, less than that if you kind of count certain operators as like the same.
Mm-hmm.
So it's like we're basically breaking up these like 1,000 ops into like tens of ops. You have the option to use those tens of ops directly if you want for your workload, or you can just stay in the PyTorch ecosystem, go to Onyx, and then drive that through our software flow.
Perfect. Yeah, and I think for those that have been with us on the journey, we have a lot of tools around this, right? Where you look at Groq Flow or some of the other things to help optimize when you're converting over. And this is the advantage of being deterministic, right? We can know at compile time exactly how things are going to perform, what you're missing, what your needs are, where you could optimize further. So there's a lot of good resources that we can actually offer the developers as well to try to improve developer velocity. And that's one of the goals. How do we accelerate time to production? That's a metric that we measure a lot. Well, gentlemen, this has been really, really fun. And I think the chat conversation has been very active. So I want to thank the community for joining us today.
That was good, but not great. But no, this is... I hope you guys understand. By watching my stream, you're essentially seeing the future before everybody else. You're essentially getting a look into the future of computing. And you're aware of things other people aren't aware of. Wow. Buy LPUs now. That's what I'm waiting for. I'm waiting for like LPUs. I don't know how much they cost to make. I haven't seen anything like that. I'm not sure how they actually talk about it. That's the thing. It'd be interesting to see when because I feel like maybe they'd be keeping it vague. So maybe they're doing everything vague, like in New York. That way they can have a lot of quality control and also not let people know their exact way they're doing it. But I don't know enough about it to say if that's true or not.